name is Teacher. What's a neuron?
What's a neuron? Let me show you. Hit it.
I'm that neuron. Been that neuron, still that neuron. Will forever be that neuron.
Forever be that neuron.
Yeah.
Yeah. I'm the main brain component, make decisions for your homies, fire down my axon, trying to signal out to other neurons.
Yeah.
I'm way too negative, just my rest of potential crazy all the factors that contribute to my negative 70 volts milli.
Bad neuron, still talking mad, firing potential like water, I'm flowing all or nothing. I would never trip on these PSPs if I had yo, that's my vesicle, it's the mover, so it has
I'm a neuron.
Yeah.
Axon, cell body, dendrites.
Yeah.
Synaptic cleft, terminal, buttons.
Yeah.
Firing crazy, what's happening?
Neuron.
What's happening?
Neuron.
I'm a neuron. Let's get into depolarization.
Yeah.
Getting past that threshold potential.
Yeah.
From negative 70 to 50, what's happening?
EPSD.
What's happening?
Here we go, dendrites, we up, taking all them entities with spiny things, coming out to pick up on them signals, then we move into the cell body with all them proteins make, getting ready to send the signal, gotta move it forward, phase, moving NAs away, jumping down the axon from node to node, too much speed, wrapped up in miles, I lose the flow.
Lose the flow.
Play a game, send that signal forward, go.
Gotta send it.
Send it down.
I'm a neuron.
Yeah.
Electric to chemical to electric. Ionotropic and metabotropic.
Yeah.
Gotta get to that potential. That potential.
Negative 50.
I'm a neuron.
Yeah.
Axon, cell body, dendrites. Synaptic cleft, terminal, buttons. Firing crazy, what's happening?
Neuron.
What's happening?
Neuron. Now we get into the terminal ooh. This is where we letting go of all those MTs ooh. We got that docking, priming, then fusion ooh. Then memories be fusing, then we lit. A. It's protein and receptor, lock and key ooh. It won't happen without the calcium though. Then after release, let's go back to negative 70. Hyperpolarized, the cell can't send until it's back ooh.
But after we back, we send in a million more signals. Aye.
Lit.
Okay.
Honestly,
Hi everyone, so really quick we're going to recap the actual structure of neuron and the functions of each parts of it. So beginning with the dendrites. The dendrites are receiving signals from other neurons, so this is going to be via EPSPs or IPSPs. After receiving these signals are going to go down towards the axon hillock. And the axon hillock is actually where the impulse is generated for the neuron. So if those EPSPs and IPSPs add up to above the negative 15 millivolt threshold, we're going to be able to generate this action potential that's going to continue to flow down the neuron axon. So beginning with the axon, we have these areas called myelin sheets. And myelin sheets, the purpose of them is essentially to increase the speed of the action potential. And this is done by the fact that the myelin sheet protects the axon from the further diffusion of ions, such as Na plus and K plus. Then once you get to the nodes of Ranvier, these are the areas of the neuron that are actually going to allow the diffusion of ions. So we're going to have Na plus coming into the cell and K plus going out of the cell. This is going to allow there to be enough concentration of ions to continue moving down the axon, obviously protected in the myelin sheets, and then more diffusion at the nodes around here. So once this action potential, it obviously is going to retain its strength, gets to the end of the axon, it's going to reach the axon terminal. The axon terminal is essentially going to form junctions with other cells, so to allow this signal to continue down via calcium, which is going to help with the priming, docking, and fusion of neurotransmitters, which are going to be released and accepted by receptors of the next neuron, go back to the dendrites and allow this process to continue.
okay. These are the factors that keep resting potential negative. We have the NAK plus pump, and then diffusion, electrostatic force, and selective permeability.
Line in the song that said it's all about lock and key, and that's talking about the neurotransmitters which bind in a lock and key formation. So this is the presynaptic terminal. It's where docking, priming, and fusion happen with the help of calcium. The fusion releases neurotransmitters into the intercellular space, which then they bind with receptor sites in the postsynaptic cleft and form lock and keys to create a signal in the next neuron.
Okay, so there are two different types of receptors in the cell membrane. We have ionotropic and metabotropic. Ionotropic works by opening an ion channel. It can be made up of 4 to 5 different subunits. Metabotropic works by having an associated G protein and by using secondary messengers. These secondary messengers lead to indirect actions that depend on the protein that is attached to this receptor. And then, one of the most important things in the cell membrane, the sodium-potassium pump. So this is going to pump 3 NAs out of the cell and 2 potassiums into the cell.